Now that we've got a stored procedure for querying in the database, I can show you how to use the raw SQL methods to query using stored procedures. This is possible with either of those methods. You can use from SQL raw with a formatted string or from SQL interpolated with an interpolated string, just like we did in the earlier queries. Both of these methods allow you to pass in any parameters expected by the procedure, and EF Core will know how to pass those along to the database in the manner that it expects. My author's published in year range procedure expects two integer parameters, the beginning and end year of the range you want to filter on. In my first method, I'm using from SQL raw and a formatted string. The string starts with a procedure name, author's published in year range, followed by two placeholders, 0 and 1, in curly braces. And then after the string, I list the two year values, 2010 and 2015, and the string and parameters are all separated by commas. Notice that I didn't use the exec statement in the string. This will work with or without using the execute, so I've skipped it. The next method is using interpolation. And remember, for both formatted or interpolated strings, you can use values for the parameters like I did with the previous query, or you can use expressions. So this time, I'll create start and end variables for the start and end years. Then remember, when I create the string parameter for from SQL interpolated, I need the $sign before the string. And instead of the placeholders, I just put the variables start and end into the curly braces. And here's the result of the first query. I have the two authors that I expected to get returned. And in the log, here are the two parameters that got passed in, and then it's calling the procedure. The interpolated string works exactly the same. I get the same pair of authors because the same command with the same parameters was sent to the database. Remember that you can compose on top of either method, whether you want to do things like sorting, perform additional filtering, or even run it as no tracking. And don't forget that you can use include. And that's important. One of the rules for raw SQL methods is that your SQL or the stored procedure can't return shaped data. But by composing include on top of the raw SQL method, you can still bring shaped data back. And remember the other rules that we learned about these methods. Because I'm querying from the author's DB set, the shape of the result of the procedure must match the author type, not just in the properties, but also the column names need to match the property names. That way, EF Core will know how to create the resulting objects. Being able to query stored procedures that return randomly shaped data into an anonymous type has been on our wish list for a while, but it's not supported yet. You have to use a DB set, which predefines the types that it anticipates. Also note that if EF Core isn't able to figure out the SQL that you've passed into any of these methods, you'll get an exception at runtime. The compiler will not be able to figure that out. And don't forget to check the documentation for additional guidance on using these raw SQL methods. So far, we've worked with entities that map to tables and can be updated by EF Core into the database. Keyless entities give us another way to map entities so that EF Core will always consider them to be read-only. But what's really special about this feature is that it also allows you to map to views and tables that have no primary key. There was a time when Entity Framework Core had no way to work with entities that don't have a key, and that's because the change tracker relies on those key properties. But now EF Core can comprehend keyless entities, and it won't worry about needing to track them. Keep in mind that if you want to have the flexibility of an entity that can sometimes be updated and sometimes be read-only, you can still use the no tracking queries or specify the query tracking behavior from the DB context. There's also another feature that lets you map an entity to both a table and to a view at the same time, and EF Core will use the view for querying and use the table for updates. I won't be spending any time on this feature, but you can find a link to more information about it in the resources for this module. The feature we're focusing on here, the keyless entities, is more about being able to have entities with no keys, and therefore they're always read-only. And because one of the great benefits is being able to map them to database views, it's time to add a view into my database. The editors recently requested a way to get a list of their artist pool and find out which authors they've designed book covers for. So the team decided that a database view was a great way to get that list and asked their database guru to work out the SQL for a view called Authors by Artist. And then someone on the team used migrations to make sure that gets into everybody's development databases. Here's a look at querying the view directly from the database so you can see what the results look like. It returns all of the artists, and if they've worked on any books, it lists the authors of those books. Some, as you can see, haven't even worked on any book covers yet, so their authors are null. The keyless entity need only match the schema of the view results. So that means I need a class with two strings, artist and author. And because author might be null, I'm specifying that this property can be a nullable string using the syntax of appending a question mark to the string type. And of course, there's no key property in here, just the two strings. Now I can create a DB set to make it easy for other devs on the team to write queries. Here's the new DB set in my context, and I gave it the same name as the view, Authors by Artist. There are still two more steps for configuring this, but I want you to see what happens if you forget to perform that step, because it's really easy to miss, but the compiler won't catch it. EF Core will catch it at runtime when it's trying to work out the data model. So I'll go ahead and add a query against this new DB set using toList to execute it. When EF Core tries to build the data model at runtime, it throws an exception. In fact, if I had just used the visualizer from EF Core Power Tools, I would have been alerted to the problem as well. So remember to take advantage of the tools that you have at your disposal. The exception says that the entity type Author by Artist requires a primary key. And it's even more helpful because it also tells you that if you meant this to be a keyless entity, then you have to add the has no key mapping in the DB context. So let's go fix up pub context. In the onModelCreating method, I've added a new mapping to the model builder for the Author by Artist entity using the configuration method has no key. But there's another problem which right now is invisible. By default, EF Core maps all entities to tables, and therefore it's going to expect that there's a table called Authors by Artist. And if I created a new migration, it would create logic to create that table for me. I definitely don't need it to happen. I already have my Authors by Artist view in the database. So what I need to do is explicitly use the toView mapping with the name of the view, Authors by Artist, onto the Author by Artist entity. I'm not using this to fix the naming, where my view name might be different than the DB set, although that would be another bonus, but it's something you always need with views. And because the view name happens to match the DB set name, I could avoid typos in a magic string by using C#'s nameOf method and passing in the DB set name, which will give me a flawlessly spelled string. Another important thing to be aware of is that this won't affect migrations. Migrations wouldn't have the ability to figure out what that view should be. That's why I predefined it and created a migration for it. So right now, even though I've just made a change to the model, it's a change that migrations would ignore. And if I created a new migration, both the up and down methods would just be empty. The other important aspect of the has no key method is that EF Core will never attempt to track this entity when you exit queries. Remember, I said this was EF Core's way of supporting read-only entities. So you don't have to worry about using an as no tracking query. And if you try to explicitly force tracking with the as tracking method in a query that's using keyless entities, EF Core is just going to ignore that. Now we can finally execute a query on our view. I'll start by just getting a list of all the artists with their authors. And that's easy enough. EF Core just creates a query against the view, and as it does with any other queries, it materializes the results and creates a list of objects, although because they're keyless entities, it does that without change tracking. You can use other link methods as well. Here I've got a query that uses first or default, and then another one that filters on the artist name using the where method. Because views are composable, EF-Core creates SQL that just performs standard queries against the view. Again, it's no big deal. And the only reason this last query isn't parameterized is because I just pushed the predicate directly into the LINQ query. And at the end of my method, I grabbed the debug view so I could show it to you, and it's completely empty, which is expected because the change tracker doesn't track the keyless entities. And I know I've mentioned that a few times, but I wanted you to actually see that. You'll have to be careful about using dbset methods on the dbsets for keyless entities. For example, the compiler is perfectly happy with using find because it's a method of dbset. But when it's attempting to work out the SQL at runtime, it will realize, whoa, wait a minute, there's no key here, and it's going to throw an exception. In addition to querying the dbsets with raw SQL, it's possible to send raw SQL to the database for other tasks using the execute SQL raw and execute SQL interpolated methods. But these aren't dbset methods. They're methods of DB context property we haven't really talked about yet, although you did get a peek at it in the very first module of this course. It's the database property. We use that to let Entity Framework Core create a database on the fly for us using the ensure created method. So EF-Core lets you drill through the DB context to the database that it's tied to through configuration. And with that, you can drill to execute SQL commands on the database. But the execute SQL commands can't be used for queries. Not only can they not materialize query results, the only result you'll ever get back is the number of rows affected by whatever command you sent. Like with the raw SQL commands for querying, you can pass in SQL or call procedures with execute SQL methods. I'm going to use a stored procedure to finally show you a handy way to delete entities without having to first pull them into memory. I've hinted at this a few times in this course, so here we finally are. I've added one last stored procedure into the database using this migration. The procedure this is creating, called delete cover, takes a cover ID and deletes it from the covers table in the database. And thanks to Cascade Delete, it will also delete any artist cover rows connecting that cover to artists. I've already updated the database with this migration, and here's the procedure listed in the database in SQL Server Object Explorer. So let's use that procedure to try out the execute SQL raw method. I'm now drilling from the context instance into its database property and then its execute SQL raw method. As before, we'll need to use a formatted string to specify the procedure and then pass in any parameters. Just one in this case, say a value that was passed in from another method. And I just assign 10 to it, since I know that that does exist in my sample data. When I'm calling the procedure, I can use it with or without the exec statement, as you saw earlier. And here's the SQL generated by EF-Core. The value of the cover ID is parameterized in the command and then passed in when executing the stored procedure. Remember, I said that these execute SQL methods will return the number of rows affected. And here you can see that I captured that result, and the value is 1 because there was only one row deleted. If you were using a procedure which performs some action on multiple rows, that result might be useful information to send back to your user. You also have the option of using execute SQL interpolated and building an interpolated string from the stored procedure's name and the cover ID parameter. And that gives you the same command sent to the database and the same result.